Hi. So what I'm trying to do today is demonstrate the concept of Newton's second law, or commonly known as the momentum principle. In order to do so, I'm going to show you my demonstration and compare it to my expected result, and then try to explain why or why did it not deviate from my expected result. So what is Newton's second law? It states that the net force is equal to mass times acceleration, or more commonly known as F net over mass equals the change in velocity over the change in time. However, for this lab's purpose, we're going to assume that acceleration is equal to 0 because we need to demonstrate constant velocity, which states that acceleration is 0. By doing so, we plug in acceleration is equal to 0 and then find out that F net is equal to 0. One thing to note is that mass has no role in constant velocity whatsoever. In order to do this lab, we need to make several assumptions, some of which include that the initial velocity is equal to average velocity, velocity will be constant throughout the video, ball is traveling on a frictionless surface, and no other forces will be acting on this ball during the experiment. The ball travel, and one other one will be the ball travels in a straight line and will never change its trajectory ever. So now what I'm going to do is show you a demonstration of my experiment, which is going to be of a foam ball traveling on the horizontal surface to the left of my set origin. As you can see, the ball travels in very constant velocity, and that assumption is confirmed graphically on the right with a position versus time graph. It has a very straight slope, which is a good signifier for the fact that it has constant velocity. So now, what do we get out of that? We got that the initial position was about 0.003 meters to the right of the origin, and then that the initial velocity, which is derived from the average velocity formula, and the first 2 points of my collected data, is about negative 0.757 meters per second, and it traveled for about 1.66 seconds total. So now we're going to plug that into my Python simulator file, and then it's going to generate a expected path for my experiment. As you can see, the trajectory of the expected ball path is very similar to the one that I just showed you via my experiment. And that the lab data states that it traveled for 1.67 total, and it for a total of negative 1.26 meters, or 1.26 meters to the left. So now we're going to compare the data from the two experiments. I plugged in all the data points from the predicted trajectory onto the left side of the Excel file and the observed trajectory onto the right side of the file. We are evidently able to compare the two and see that the orange line, which is the observed position, and the blue line, which is the predicted position, are very close to each other. However, evidently they are not exactly the same, and there's some of the reasons why include the fact that there was a friction that slowed the ball down, which is why it traveled shorter than expected, and that the ball might have possibly also deviated from its expected course, and that it might have traveled further to the ball, to the camera or away from the camera. Now we're going to go on to answer the two lab questions. The first of which asks, what if I were to flip the axes? The ball will still travel in a straight line regardless of which orientation it travels in, but just a different direction and same speed. This is because the direction has no effect in speed, and therefore it will maintain constant speed throughout any orientation it travels in. Graphically, it will mean that it will have different slopes due to the fact that it will revolve around different axes, and then the graph generated would be different because it would, as I said before, it would revolve around different axes. Next, what does it mean when the net force is equal to 0? All the forces in the system would negate each other so that the object would travel in constant velocity. One such example, as demonstrated in my experiment, would be the fact that gravity, which pulls the ball down towards the center of the Earth, and the normal force, which pushes the ball up away from the center of the Earth, negate each other because they are equal and opposite forces. This results in a net force equal to 0, and ultimately plays no role in the fact that my ball travels in constant velocity. As a result, my experiment was a very good demonstration of what constant velocity should look like. However, as I said before, some sources of error would include the fact that the ball might have skewed from its path and traveled towards or away from the camera, or that the fact that friction actually plays a part in this role. Thank you.